participants, I welcome you to this fourth day of this FDP. I want to introduce today's guest and eminent speaker, Dr. Amol Bhopale sir. He has done his BE from Government College of Engineering, Amravati. He has completed his M.Tech from NIT Surathkal and his PhD from VNIT Nagpur. He has 4 SCI papers and many scopus and conference papers to his credit. He is currently working as assistant professor in IIT Nagpur. Now I request Dr. Kuthe sir to welcome Dr. Bhopale sir with sapling. Thank you sir. Now I request all the participants to be seated and please attend to our mind-blowing session on machine learning topics. Okay. So.
First folder. Yes. Thank you, sir. Very good morning. Myself, Dr. Amol Bhopre. Uh, Basically, my area of expertise in natural language processing, text representation, and I thoroughly worked on the transformer architecture. So, in my research work, I actually proposed three different frameworks. Obviously, on a text data itself, wherein I have used a transformer in one of the proposed framework to increase the results, to increase the accuracy or relevancy of the data. So, as a topic you can see here, it is a visionary AI, generative vision transformers. So, in today's discussion, I'm going to I'm going to focus more on the transformer vision transformers. So how these transformers are now applied from the text domain to this image processing domain, and what are all benefits that we can gain out of it. So I will start with the introduction, the basic fundamentals. Quickly I will recap, or I will review the fundamentals of ML, machine learning, deep learning, and computer vision. Followed by I will discuss about the transformers and how we have moved from the traditional approaches, that is CNN, RNN, to the sequential models, followed by the attention mechanism in sequential model, and then how this attention model is incorporated in a transformer architecture, the encoder-decoder architecture with the help of attention mechanism, and what are all benefits out of it. Then how this transformer is applied or used in a computer vision side, that is vision transformers. So it is VITs. Then we will see some of the opportunities and challenges that are faced. So this is the outline of this today's seminar. So basically, this fundamentals of machine learning, as we all know, like what exactly is machine learning. So machine learning is basically to empower the computer to learn from and make predictions based on the data patterns, thereby enabling decision making without explicit programming for any scenario. So it is a kind of a model, or it is different from the normal programming. Okay, so wherein we have input, we have output, and what we are trying to do, we are trying to model, or we are trying to train a model for a given input. It is supposed to give the output. It is supposed to give that output. So basically, machine learning is something designed to predict the data from a given input values. Okay. There are different types based on the learning process. Basically, we have different types of learning. So that is, you can see here that supervised learning is one task. So where the labels are provided. So labels means let us say that example of cat and dog image data set. Okay, so we have corresponding labels that the given image is of a dog or a cat. So that cat and dog are the labels. If we do not have those kind of labels, so in most of the cases we have data which do not have labels. The 1024 by 1024 resolution. So that 1024 cross 1024 means these many pixels are there, and each pixel has a value from 0 to 255. That is RGB values based on that. So these are the features for that particular image. Okay. So based on those features, we usually form the clusters. And then that comes under the unsupervised task. One more thing is there that you can see here, that is reinforcement learning. So reinforcement learning is something that is where the agent learn through trial and error. The best example is the chess game on a computer. Okay. So initially when you start playing chess game on a computer, you will see that in first few iterations your system might not be defending properly. But after some time, after playing some hundreds of games, your system is now learned what moves that you are taking, and based on your moves, now your system is also taking those moves. So how it has learned? It has learned basically, it has taken that move first, and if the penalty is applied on that move, then it is not taken into after next iteration. So that is how the reinforcement learning works. Okay. There are many algorithms in machine learning, like understanding algorithms such as decision trees, then support vector machines, clustering techniques is crucial as they dictate how the model learns from input data to achieve the desired outcomes. So based on the type of data, we have many algorithms that we need to apply. That is linear regression algorithm, a foundational statistic method that models the relationship between the dependent variable and one or more independent variables. So in most of the cases, linear regression or logistic regression are used by the industry people. Okay, so just to see the effect of a independent variable on a dependent variable, x and y problem. Next is decision tree, a versatile model that splits data into branches to classify based on a feature values. Okay, so I'm not going into details of it. I hope that that you have already gone through these details. Okay. So next is support vector machines. So these algorithms aims to find the optimal hyperplane based on the vectors. So what we usually do, we usually plot basically we usually plot the points. We call it as a vectors. Okay, we plot those points in the feature space. Okay, based on the values which are provided, and then we try to find out a hyperplane which can separate out these all these vectors. Okay, so we are trying to maximize the margin. Okay, I'm not going into details of it because it will take a lot of time. Next is ensemble methods. Ensemble methods, by combining multiple models, ensemble methods can increase the predictive accuracy and robustness. So ensemble means combining multiple models, assigning some weights to the model which are performing well, and giving some penalty to the models which are not performing well. So these are basic ML algorithms. Next is deep learning. So what exactly is deep learning? So why it is required? All these are the interrelated fields. This AI, artificial intelligence, then machine learning, deep learning, computer vision, NLP, all are the interrelated domain. All are interrelated fields. Okay, so we have to have the knowledge of all these fields if we want to work in this area. Okay. So deep learning is basically a subset of a machine learning which is which is using neural networks with many layers that can analyze data with high level of complexity, making it especially powerful for tasks like image and speech recognition. Okay, so initially it is assumed that maybe before 2010 or maybe 2 decades before, like in 2000, it is assumed that ML techniques are required for the ML techniques are basically required to work with the text. Okay, and these DA techniques are required to work with the images. Okay, but somewhere in 2003 there was one model which was proposed. The researchers have proposed one model, that is a deep learning model, to work on a text data, which is again studied in that year. Basically, that model doesn't get the focus from the other researchers, but somewhere in 2010, another model proposed by the same researcher. I'm not remembering the name of that, but actual breakthrough got in 2013 by Thomas Mikolo. So you can note down the name of these people if you are really interested in doing work in this direction, because these are some of the researchers which have given, which have shown to the world that these models can be applied. So Thomas Mikolo is one person. In 2013, he has applied a simple feed-forward neural network architecture. It is a 3-layer architecture basically, to the text data, and it has applied that model to generate the embeddings. What you say word embeddings nowadays. So word embeddings are first introduced in that paper by the Thomas Nicolo, and later on, from researchers from the that model is word to vec model. Okay, that model which is used for generating the word embedding. The first model was word to vec model. Later on, there was one more model proposed by Facebook people, that is fast text model. Stanford people introduced the GLOBE model, GLOBE model. Okay, so all these models are basically working on a text data, but using deep learning architecture, and they are surprisingly they are getting whatever they initially get it for the image data. Now they are getting it for the text data. Okay, so the results are improved with the introduction of all these deep learning models. Okay, so neural network explained these networks mimic the human brain processes, utilizing interconnected neurons to transfer input data through successive layers. Okay, so as a programmer or as a researcher, I have a choice to introduce many layers. So whatever, like in computer vision domain, basically you must have, or in a deep learning domain itself, you must have heard about CNN, convolutional neural network, then recurrent neural network, then ResNet, residual networks. Okay, then this GAN. Okay, so all these are basically, we have introduced multiple layers with some additional features, and the sole task is to improve the accuracy in the classification, improve the accuracy in the prediction. Okay, or to reduce the error or loss in the prediction task. Okay, so we have introduced those layers. Okay, so obviously if I am increasing the layers, if I am, like you are all we are working in the organization, so if we increase the hierarchy, obviously time consumption is more. Okay, so if I introduce a layer in a model, in a network, that means that layer is taking some time. Additional computation cost is also required. Okay, and by the introduction of this layer, it doesn't implies that every time we will get the good accuracy. Okay, so that's why if you have studied ResNet, there are multiple layers. In ResNet, basically we have some 34 layers, some 50 layers, 159 layers, 150 or even 200 or 1000 layers also. So, but there are some issues with increasing these are the computational issues. One more major issue is the gradient descent, or vanishing gradient, or exploding gradient. Okay, vanishing gradient means if I am passing some information to sir is passing to ma'am, then ma'am is passing to this. And last person will not get the information whichever I passed, whichever I transferred. So that information loss is there. That loss means the gradient descent, vanishing gradient. Okay, that important part is actually vanished. Or sometime, if I am giving one byte to a media person, that media person explode that particular part. So that is the exploding gradient descent. That is called as. So with the introduction of these layers, these things come into the picture, and how to deal with that. Okay, so let's quickly go through this. So basically, this there are use cases of deep learning. So deep learning is utilized in cutting-edge applications such as natural language processing, autonomous driving, medical imaging analysis, showcasing its versatility and transformative capabilities. As we have discussed, like these deep learning techniques now are applied in the domain of natural language processing, then image processing, autonomous cars, whatever AI now you can see are all because of the deep learning and ML models. So some of the architectures of deep learning that may be required. These are the basic fundamentals which are required for the computer vision task. Okay. So this CNN are specifically designed for efficiently processing structure, grid data as images. It utilizes convolutional layers to capture the spatial hierarchies in a visual data. Okay. So initially, like you simply understand that these deep learning models or machine learning models are the programs, okay, simple programs wherein we are giving some input and we are giving input as well as output, and your model is learning out of it. Okay, once a model is trained, now you will be giving some values or some test data or validation data. Okay, and on that test data we are going to see what exactly the output from the given model. So basically, with this CNN also we are giving input as an image. Okay, what we are doing, we are extracting the features from the image. Okay, so that feature can be, as I said, for an image, the features are its pixels. Okay, so basically these pixels are treated as a features. These pixels of the image are treated as a feature, and those features are now given as an input to this model. Okay, and now CNN has multiple layers inside. So what we are trying to do, we are trying to train a model through multiple layers without additional information. Here without additional information. In recurrent neural network, RNNs are adept at handling sequential data. Okay, so making them ideal for applications like language processing where context matters over time. Okay, in an image, simple image is given as an input, and now this image, from that image we are actually labeling, we are trying to label that image, whether the given image is of a dog or a cat. I am taking very simple example. But CNN models are basically are not designed to deal with the sequential data. Okay. If I have a video, if I have a video clip, and now I have extracted the images or frames, frames per second. Okay, so in 1 second, like let us say I have a video of 2 minutes, so total 120 seconds, total 120 images I have. Now if I give that image, all those images as an input to CNN model, that CNN model won't be able to understand what exactly the content of the previous image. However, if I give this input to the RNN model, my RNN model is now able to process it in a sequential manner. So whatever the data or whatever the information is present in that entire video, that entire information can be given to that model, and that model will generate it for the next task. Basically, that is the final goal of that model. Okay, so RNN are basically designed to process the sequential data. Okay. Next is generative adversarial network, that is GANs. Okay, GAN. So GANs consist of two neural networks contesting against each other to generate new data, leading to extraordinary capabilities in image synthesis and augmentation. Okay. So I'm not going in details of GAN because GAN itself is a big topic. Okay, and it is an advanced topic. I'm more focusing on the last part, that is transfer learning. Okay, so transfer learning, you can read it here, like this technique leverages pre-trained models on related tasks, facilitating this knowledge transfer that enhances model performance, especially in a data scarce scenarios. Okay. So what this transfer learning is, like, so somewhere in 2017, this transformer got introduced. In 2018, attention, all you need is one paper by Vaswani, some 44 pages of length. So in that paper they have introduced the attention mechanism. Okay. Why it is required in RNN model, you can see here that in the first line itself, that is RNNs are adept at handling sequential data. Okay, so as I discussed earlier, this additional task, like if I am using a sequential data, basically if I am using a sequential data, there is an issue with the gradient descent or vanishing gradient. So these RNNs are not built to deal with that vanishing gradient. Okay, so that's why attention mechanism is used. हम लोग जैसे देखते हैं कि a student is not performing well in a class, if there is a particular student who is not performing well in class, we give more attention to that particular student. Literal meaning है इसका in this field also, that there are some important words, so if I am providing extra attention to those words, those words, like if I am telling sir that sir this is very important word, you should not miss this word when you are transferring the information. Okay, so a more weightage and more focus is given to that particular word, so sir will ensure that while transferring he will not miss that word, so basically that word will be part and he will tell the same information to the next person also. So you please, this word is very important, don't miss that word while you are transferring the data. So likewise, the attention is throughout all layers, this attention is provided to that particular word, and that particular word is now at the last layer. Okay, so that is the mechanism of attention. Okay, there are few more extra features in that will be discussed in detail in the following slides. Okay, so basically if I am providing that attention to a specific word, that means I am not losing the information from the given input. Okay, so same applied, same part is applied, same mechanism is applied to the images as well. Okay, this visual transformer. So that is how that visual transformer comes into the picture. Okay, what we are trying to do, we are capturing one image. Now if I capture an image from this place, if I see that the few places are vacant and few places are occupied. Okay, so let us say that I am transferring entire image this to my model, okay, to my deep learning model or transfer any model, any deep learning model. And my model is now trying to learn out of that image. Okay, so what it will do, it will see like how to identify the objects are there. Human beings are like objects now. How to recognize the objects are there based on some features, based on the pixel quality, based on the values in the pixel. Okay, so what I will do, I will split the image into patches. Okay, that one portion this side, one portion this side, another portion that side. So total, let us say that I am making a grid of 3 cross 3. Okay, so that means each patch will have some values. Okay, and now I am telling my model that this particular patch or the part of this image has participants present. Okay, so extra information or extra attention is now providing to this particular patch with this particular patch, and now this information is now we are transferring it through the multiple layers of the transformer. The transformer consisting of encoder decoder architecture. Okay, so in RNN also what we do, we actually transfer the value from one block to another block, and finally we will have one encoder block from which we basically get all the data at that encoder part, okay, of the same image, and now we are transferring it to the decoder part, and now decoders will start decoding the entire image or whatever the labels are there. Generating text or the captions from an image is a very good example for this RNN task. Okay, RNN means attention mechanism. So this transfer learning is something that is as I said earlier, if we are increasing the number of layers, more computational cost, more number of resources will be required, more data will also be required. So it is not easy for a single person or institute to host all those resources, because these are very costly resources. Again, it has some drawbacks, heat emission power, carbon print footprints, so all this tasks. So whatever you see, like GPUs, you have heard about GPUs and TPUs. So all big institutions such as Google, GPT, OpenAI, all these are actually using a lot of data to train such models on the high-end resources or on high-end computer systems, and after after that they are actually hosting those or they are providing it to the entire world. Like this is the model which is trained on a specific data. Now you can use that particular model to fine tune it with your data. The model is now जैसे हम लोग स्टूडेंट्स बनाते हैं, स्टूडेंट्स को सिखाते हैं, जैसे बनाते हैं, तो फर्स्ट टू फाइनल ईयर हम लोग उसको पढ़ाते हैं सब कुछ. आफ्टर फाइनल ईयर he will get placed somewhere. XYZ कंपनी में प्लेस हुआ है. नाउ उस XYZ कंपनी में whatever we taught that person, whatever we taught that student from first year to final year, all things are not required. Only the attitude part, the learning attitude is required, then the logical part is required, and some programming skills are required. Okay. Then what that company will do, एक उनको एक trained model मिला है ना, जैसे 12th pass student and graduate student, there is huge difference. Okay. So if I am giving that 12th pass student to the company and the graduate student that company to that person, maybe that will take only 1 week or maximum 2 weeks or 2 months, not more than that. It is not at all taking 4 years. Okay. So that is how like this what they are doing, they are training that person. So that is called as the fine tuning with their data. They have data sets available, they have outputs. Now what they are doing, they are assigning that student to that data to analyze that data and generate the outputs, and meanwhile they will cross check whether the outputs which are generated by the student are correct or not. Okay. So that task is considered as a fine tuning task. Okay. Some parameters are also there. You might have heard about the parameter fine tuning, hyperparameters. Okay. So those parameters means for how much time a person should learn in a day. So that time can be one parameter. Then extra resources if required by that person, extra stuffs required by that person. All these are the parameters. All these are the hyperparameters which may vary from student to student, which may vary from one person to another person. Okay. So this is how like this transfer learning works in the computer domain as well, computer field. So we have the open source trained model by all these big organizations, and we can use it easily. Okay. So these techniques leverage the pre-trained models on a related task, facilitating knowledge transfer and enhancing the model. Like just say related task means if a person is trained in computer science department, तो वो computer science domain का knowledge लेगा. If a person is graduate from the civil department, then he has the knowledge from the civil department. Then we can fine tune it accordingly. Okay. So overview of this machine learning and deep learning. So ML encompasses a variety of algorithms that allow computers to learn from the data and then make the predictions or decisions. Whereas in case of deep learning, okay, in case of ML basically all features are human curated features, or the features can be understood by the human being. Whereas in case of deep learning, if you see deep learning को हम लोग क्यों black box बोलते हैं, because whatever happening in these layers are not at all possible for a human being to understand. Transferring the numerical values, transferring the values from one layer to another layer, you cannot understand, you cannot relate it with a real world example. Okay, these are simply values. Whereas in case of machine learning, for a dog and for a cat, I know that there are some features. The color of a dog, color is one feature, number of the legs, then ears, then height, weight, are all features basically which can be understood by any human being. But in case of DL, and for a human being it is difficult to extract more than 20 features. Okay, if I ask you to tell me 20 features of a dog and a cat, so it is difficult. More than 20 it is difficult. But for deep learning model, what we do usually, we extract some 100 features. We extract some 200 features. But these features are not at all understood by human being. All these are numbers. All these are numbers. Numbers captured from different part of the image, or numbers captured for different set of words. Okay. So this deep learning is a subset of machine learning characterized by the use of neural networks with many layers. Okay. This methodology excels at capturing complex patterns in the large data set. So that is why, like, since it has a number of layers, so it is able to capture all the complex patterns. Okay. So historical context and relevance from early methods relying on the handcrafted features. Human curated features are also called as the handcrafted features over here. The field has seen evolution alongside computational power and the availability of the big data. The ability of a deep learning to automatically extract relevant features from the image has revolutionized performance in computer vision. Okay, so these deep learning models are basically able to automatically extract the number of features from any given data. So that is why these are more important. Okay. Then we will shift to the computer vision. Okay. So computer vision refers to the field that enables computers to interpret and gain understanding from the visual information within digital images or videos, allowing them to see in a manner same as to the human vision. So what we are trying to do, we are providing these images as an input or a video as an input. Now I can see, like, I can count the number of participants present. So as a human being, I have that ability to count. But if I capture the image and if I am simply giving it to any XYZ system, so that system doesn't have inbuilt, that system doesn't have that ability to count the number of objects or the number of faces. Okay. So what we are trying to do in computer vision is basically to train your model, to analyze those images, analyze that video content. Okay. So we are providing a vision to the computer as we have as a human. Okay. Some of the real world applications are from autonomous driving systems. Tesla is one of the best examples for computer vision. Okay. From autonomous driving systems to facial recognition technologies and medical imaging diagnostics, computer vision is revolutionizing various sectors by enhancing automation and assisting in decision making processes. What Tesla does? Tesla is continuously capturing the images from the road. Okay. And it is giving those images as an input to the model, which is there in that car itself. Okay. And within a fraction of seconds, that model is analyzing those images, whether there is any object passing through, whether there are any obstacles present in a road. If it is there, then it will make the decision whether to stop or whether to continue the drive and when to turn. Okay, so basically all such kind of vision is provided to the machine with the help of this computer vision. Interdisciplinary nature, so computer vision intersects with various domains like artificial intelligence, robotics. See, when your system is trying to behave like a human, extra intelligence is provided to a system. Calculator बहुत basic intelligence होगा. Okay, calculator can be considered as a mechanical intelligence. But looking at the context, like just analyzing the context, and after analyzing that context, making a decision, now your system has started behaving like a human. So no wonder after 20-30 years, we may see robots doing other stuffs, all the stuffs that we are doing nowadays. So robot may do, will do all these stuffs for us. We will have now we have virtual personalized assistants. In mobiles we can tell Gemini model or the Alexa to please remind me at this time, or to please set alarm for tomorrow, or whatever the task that we want. But definitely after 20 years or maybe after 30 years, we will see robots passing through this corridor and doing all the mechanical tasks. Okay. So So those robots are basically designed to do a special set of tasks. Or I may have my own personal assistant robot to do all the tasks which I don't want to do. Okay, प्रिंट आउट लेना है मुझे, भगाओ उस रोबोट को ना, देन कुछ डॉक्यूमेंट सबमिट करना है. सी that kind of intelligence we can provide. Okay, now it is already there. But एक सिंपल रोबोट कि जहाँ पे मुझे प्रिंट आउट लेना है, so I will tell the robot that please go and collect the print out. उसको पता है कि कहाँ से प्रिंट आउट लेना है. Why? Because over a period of time, initially I will tell the robot that please go to this room number 001 and take the print out. Then let उसको मैं 10 बार अगर वही बोल रहा हूँ कि go to room number 001 and take the print out, तो उसको 11th टाइम पे पता चलेगा कि I have to go to room number 001 and take the print out. Obviously there are multiple challenges in that, but after 20-30 years definitely those robots will start behaving like a human being. There is no wonder in that. मतलब अगर आप 30 years पहले की अगर बात देखोगे तो whatever we see today, that time भगवान ही ऐसा कुछ कर सकते ऐसा लग रहा था. Now it is possible with the human intelligence.
Excuse me, sir. Which algorithm is good and best for the computer research? Suppose I want to go that is for study or research purpose. So which algorithm is suited for best?
Yeah, that is a good question. See, deciding which algorithm is suitable for which task is altogether depending on the type of a data that you are using. Okay, so like today's session we will see the visual transformers. So according to me, these are in trends now. Okay, few years back, ResNet was there. It is still there. AlexNet is there. Okay, before that, RNN with attention mechanism was there. Before that, simple RNN and LSTM was there. Before that, CNN was there. Before that, ANN was there. So it depends on the data, it depends on the resources, it depends on the computational capability of your system. See, lot of time we give some projects to our students, UG students, and they bring something to us, some results. But they can improve those results, but their regular comment is we don't have enough amount of resources with us. We don't, like, you can use Colab, but after 24 hours that Colab will get reinitialized again. You can use the paid services are there, AWS is there. So for me, it is difficult right now to tell you which algorithm is good because it changes over the time. Okay, maybe today I am seeing that VITs are good, visual transformers are good. Maybe tomorrow you will see something more on that. Okay, so it depends on, obviously it depends on first and foremost is depends on the data, how the data you have. Okay, whether you will be able to apply that specific model on the data, and then it depends on the computational capability of your system. I hope.
We can use that is ML algorithms and deep learning algorithm or the.
So we can use ML algorithms as well. We can use ML algorithms to the all image data. The only thing required before using ML data, you have to pre-process that data a lot. You have to convert that image from the image part to the numbers or to the features. Once we generate the .csv files, just a cancer prediction, cancer data, cancer MRI images prediction करना है कुछ. What I will do, I will convert that MRI images into the .csv files. Okay, so that .csv file then further can be used by any ML model. Linear regression, logistic regression can be applied, SCM can be applied. But I am pretty sure that these ML models will not give you that much accuracy compared to the DL models. Because ML models have a limited scope. ML models are designed to work in a one direction or in a one you can say. There is no feedback kind of stuff. In some models it is possible, but in case of DL model, we see that a back propagation is there. We see that the back propagation is there. So that back propagation means we are trying to, we have actually analyzed the predicted value in first iteration. Then we have analyzed that value. We have calculated this error or loss for the batch. Okay. Then based on that error, we are trying to induce that error in a backward direction to my model, through all lengths. So in that way, those weights will get updated. So number of epochs, how many times you want to iterate that particular task, whether you want to iterate it for the 10 times, whether you want to iterate it for 20 times, that depends. Okay. So that is how we can improve the performance of the model. Okay, so sir, there are multiple parameters wherein these models will act differently or will generate the results differently. So what exactly is computer vision processing? So given an input, an image is given to you, it senses by any device, then it is interpreted by that device. Okay, so that sensing means we are converting pre-processing of that particular task. Okay, now IoT is also there, so a lot of sensors are there which are collecting the data, which can be further fed to the system. Okay, so basically in computer vision we deal with the images. Okay, we are not dealing with the text. Okay, in computer vision we broadly deal with the images. So that image is sensed by the device or pre-processed by the device. It has interpreted that the image is of so and so item. Okay, and then that device will generate some output. Okay, so this is the simple task of the computer vision. These are some of the applications of the computer vision that is in healthcare domain. So computer vision is revolutionizing diagnostic through enhanced image analysis techniques for radiology, pathology and dermatology, improving the accuracy and speed of identifying the conditions. Okay, so in healthcare domain, analyzing the images. Okay. Then in automotive industry, the automotive sector leverages the computer vision in advanced driver assistance systems. Tesla is one kind of example, or the automations are some of the examples. Then in security and surveillance, computer vision technologies are utilized for facial recognition, motion detection, highways पे generally या फिर समृद्धि पे high-end cameras are fixed, okay, which capture the speed gun देखते हैं हम लोग mostly highways पे. So these are all the applications of this computer vision. For surveillance it is used. Retail and e-commerce, computer vision enhances the customer experience through smart checkout systems and inventory management via visual data analysis, transforming traditional workflows into more efficient and customer-friendly processes. In agriculture, it basically employs computer vision to monitor crop health, then predict yield and automate the farming task. Okay, so this computer vision has, alone computer vision cannot do anything. You have to deal with, in a computer vision task, you have to process the text, that NLP is required. You need deep learning models to process all those images. You need artificial intelligence. So all these are interconnected tasks. So alone, if you are expert in a specific domain, you cannot work alone on a single project. You need to have some expertise from different domains. Okay. So as a researcher also, we need to find some of the collaborators. Okay. Key concepts in the computer vision are like image processing, the very first part. So this involves techniques for manipulating image to enhance them, to extract useful information. There are multiple image processing tasks, like augmenting the image, generating the synthetic data, then splitting that image. Okay, so all this comes under the image processing. Next is feature extraction. Once these images are processed, now your task is to extract the useful information whichever you want. So that by identifying important characteristics of a feature within an image, algorithms can reduce complexity and improve model performance in classification tasks. Okay, so this feature extraction is basically required to improve the classification results. Next is object detection and image segmentation. So object detection locates and classifies multiple objects within an image, while segmentation categorizes individual pixels to delineate structures, both key for applications ranging from robotics to autonomous vehicles. Okay, so this object detection is a very important task. ट्रैफिक पुलिस सीधे सिर्फ ये कैप्चर करते हैं, आपका फोटो लेते हैं, नो, and how it is like it then gives that image to the model. That model will tell the number जो है vehicle number, registration number. So that is the object detection task. In basically in many times you have heard like कोई animals spot हुआ है कहीं पे in forest basically. So all these are captured by the high-end cameras. All these are captured by the high-end cameras, and these cameras are detecting those objects. So human intervention is not required there basically. So we have automated that task to label whether the animal captured is a tiger or whatever the is it a tiger or any other animal. Okay. Evolution of machine learning to transformers. So how it has evolved from machine learning. We have already discussed how it has evolved from machine learning to deep learning. In deep learning there are some issues, that is vanishing gradient is a major issue basically. So that is how we then move to the transformer model. So traditional models are RNN and CNN are traditional model. Limitations of those traditional models are these traditional models face challenges in capturing long range dependencies in data. Sequential models जो है, these are not able to capture are facing challenges in capturing the long range dependencies in the data. Okay, long range dependencies means again 2 minutes का video, total 120 frames. So for the first and the 120th frame, it is difficult for a regular model to establish the relationship. Okay, so how to establish a relationship? Because this is a part of one single video, so definitely there is some connection between the frame 1 and frame 120. Okay, so there are some issues with that model. Then introduction of transformers. So as I said earlier, in 2017, the attention is all you need paper introduced transformers, revolutionizing the field by overcoming the limitations of the previous models. Self-attention mechanism is there. That transformer utilizes self-attention mechanism to weight the significance of the different words in sentence, enabling better contextual understanding. Parallel processing, unlike RNN's transformer allows for parallel processing. We will see in detail of that transformer model. There we will discuss. Okay. This RNN model is a sequential model basically, whereas this transformer model is a parallel model. We are feeding data parallel. We are actually providing it in a parallel way. Okay. Improved context potential. Again, this transformer model, since it is capturing the context, so basically with the help of that context, the results are improved now. So now let's start beginning with this topic, that is transformers. Okay, so few years back there was one movie Transformer. For electrical people, transformer is something different. For in computer science people, transformer is something different. You can see here the architecture of RNN. So RNN is recurrent neural network. You can see the first block basically. So it is widely used in natural language processing until 2017. Processing text sequentially token by token. Okay, so each input is given as a X. You can see here that X0, X1, X2, so on up to XT are all the inputs. Okay. A block A indicates that a model, each single convolutional neural network model, CNN model, okay, it has some, see this A is, let me show you here. something is going on. That A, you can see here that this is the recurrence formula which is applied in all those A, whatever indicated there. Okay. So all these blocks are basically has that formula. Different formulas, different mathematical calculations can be done actually. Okay. So all these A's are doing something. Okay. So encryption, decryption आपने थोड़ा लिखा होगा. So basically we are giving some input, we are applying some mathematical calculation, and then we are generating it. So one thing here is H0 is the corresponding output for X0, okay, which is transferred to the next A block, that is for X1. So this means that I am actually capturing the sequence from X0 to X1, from X1 to X2. Whatever the value I have at X0 is transferred now to X1. So while calculating or while generating H1, I am actually considering X1 as well as the output of the first block. Okay. For calculating H2, I am actually considering X2 as an input as well as the combined output from the first two blocks. Okay. So this is how that we are capturing the sequence. We are capturing that sequence. So why not stick to RNS? Sequential processing, it is time consuming, processing one by one. Here you can see that we are processing one by one. We have given input to each of those blocks. Okay, so we are processing it one by one. Localization is one more issue. The hidden state is mostly influenced by the recent tokens. So you can see that at H2, while calculating H2, I may not be considering the output from H0. There is a major influence of H1 on H2 than H0. But okay, this is very short. There are only 3 blocks. Let us assume that we have 20 such blocks. Okay. So whatever the value at the first block will not have that much influence on the 20th block. 20th block will have the influence of the 19th or 18th or 17th block. Okay. See, these fields are basically interconnected. So hidden Markov model भी एक concept है machine learning. Hidden Markov model actually contradicts with this. It tells us that hidden Markov model basically it considers only the immediate context. It considers only immediate context. Okay. It does not consider the context from the start to the end. Okay. So there are some limitations. So no need to have that knowledge of hidden Markov model over here. Okay. So basically, this single direction context from left to right. You can see here that we have the context from left to right. Okay. Many of the time while reading the papers, सामने का पार्ट पढ़ने के बाद हमें पता चलता है कि अच्छा ऑथर को ये कहना था. So as a human being, I have that capability. We have that capability to understand what exactly someone wants to say after reading the future part. Okay, so पेपर पढ़ने के बाद शायद मुझे कंक्लूजन में पता चलता है कि इंट्रोडक्शन में अच्छा ये कहना चाहता है. But as a system, here in this RNN model, it doesn't have that capability. You can see here that the context is captured from left to right, not from right to left. It is not two-way, bidirectional. It is a unidirectional. Okay, that is one more limitation of the RNN. This is the recurrence formula which is applied to calculate H0. We are actually considering the HT, to calculate HT, we are considering HT minus 1. That is new state is your HT. Old state is your HT minus 1 which is calculated earlier. And some function with parameter W is given over here. One more input to that function is XT. That is the input vector at the same time stamp. Okay. So that function, parameter is also provided over here. Okay. This is the basic vanilla structure of the RNN. Okay. So here you can see the one extra thing over here is tan H function. The tan edge is a activation function basically. There are multiple such see हमारा एक ट्रिगर पॉइंट रहता है, स्टूडेंट्स क्लास में शोर करते हैं तो हम एक टाइम तक सुन लेते हैं, बट आफ्टर दैट हम उनको डांटते हैं या बोलते हैं कि प्लीज डोंट मेक नॉइज. So that trigger point in a computer field is an activation function. For each neuron, some activation functions are designed. ReLU function is there, TANH is there, softmax function. There are multiple such functions. Again, it depends on the functionality. Again, it depends on the requirements. There are multiple types of RNA. So one-to-one RNA is there, that is fixed size input and fixed size output. Whatever I am, मतलब एक word अगर मैं input दे रहा हूँ तो I am expecting a single word, like a translation. Generally in translation, generally in language translation, we use this one-to-one. Okay, one-to-many means sequence output. Image captioning takes an image and output a sequence of words. Okay, so you are giving one input, one single image as an input and generating the caption. So this is a one-to-many type RNA. Okay. Then next is many-to-one. Okay. So sequence input is sentiment analysis where a given sentence is classified as expressing positive or negative sentiment. So that is many-to-one. A sentence is given and now you have to decide whether a given sentence is positive or negative. Next is sequence output. Many to many model. So in many to many model, machine translation and RNN reads a sentence in English and then outputs a sentence in a French or in any other language. So in one-to-one basically we are actually expecting only one single word for a given word. Okay. Whereas example is like image classification, one single image and one single level corresponding. Whereas in case of many to many, we are giving an entire sentence as an input to the model and expecting the sentence in different language as output. Okay. One more many to many task like sync sequence input and output. Example video classification where we wish to label each frame of the video. Okay. So these are some of the types of RNN. Okay. Next is sequence to sequence learning example. There are two examples. So sentiment classification analysis, input a sequence character or word, example tweet and classify the sequence into positive or negative. So this is basically many to one example I can say. Next is sequence to sequence learning example, that is many to many. So why this sequence is important basically. So this is language translation example, having some text in a particular language. Example in English, we wish to translate into another language, maybe French or maybe Marathi or Hindi. Each language has its own semantic and would have varying length of the. See, these different types of RNN are used in different tasks. Okay, so same RNN model with some customization we can use for different tasks. Okay. Sequence to sequence model anatomy. Okay, so basically the sequence to sequence model follows a classical encoder decoder architecture. Okay, so at training time the decoder does not feed the output of the each time step to the next. The inputs to the decoder time steps are target from the training data. At inference time, the decoder feeds the output of each time step as an input to the next one. Okay, so basically in transformer architecture, this encoder model is used. Okay, again this is at each time stamp we provide some data. Okay, so take an example of a video. So video has 2 minutes. Video has total 120 frames per second. Per second we have 1 frame. So likewise we will have total 120 frames. So let us say that if I am shuffling that data, so maybe 120 frame is available at the timestamp say 60 at t equals to 60, and some first frame is available at t equals to 100. So it would be difficult for a model to understand the flow, because ordering is also very important here. So basically, along with those frames, one extra parameter is required to be submitted, that is the timestamp value. Okay, and that will be considered by the encoder model. That will be considered by the encoder model. Do we need a break for some time? 5 minutes? Because I'm going to take 45 minutes more. If you want 5 minute break, we can gather here after at 12:45.
त्यामध्ये आम्हाला श्वास घ्यायला